Okay guys, welcome to topic 2. This is reflection. So this is the first of 3 topics in optics with reflection, refraction and lenses. So this topic is short enough. There are only 10 pages in the notes. I'll go through pretty quick, a bit of theory. Now this topic rarely is a long question. The exam, it's usually a question 12, part of a question. The experiments that go with this do come up quite a bit though. With this, I will go through it here. We'll go through it nice and slow. I'll point out kind of the key things and I'll go through the math. Some people find the math of this a little bit difficult. And I can understand why, but they're not. Take it handy. They're actually fairly straightforward. Okay? All right, so visible light, self-luminous reflection, don't worry about all those. Just worry about this one here. So what is reflection? Reflection is the bouncing of light off the surface of an object. That's reflection. Okay? So how you actually see is because of reflection. Light comes in, it bounces off objects and then goes into your eye. So you don't actually look out, you see it. Light has to bounce off a surface and then go into your eye. And then once it goes into your eyes, you can see, okay, you see it then. That's why if it's dark, the reason you don't see anything in a dark room is light's not bouncing off anything and you can't see anything as a result. Okay? So that's it. All right? That's the first one, the definition of reflection. It does get asked, even though it's that easy. The laws of reflection then, okay? So the 2 laws are the incident, the normal, and the reflected ray all lie on the same plane. And 2, the angle of incidence equals the angle of reflection, okay? So in other words, the angle of incidence equals the angle of reflection, all right? That's all, okay? They all lie on the same plane, okay? As you can see in this picture here, okay? That's it. 2 very straightforward, okay? Now, you need to understand these words because I'm going to call them the incident ray, the reflected ray, the angle of incidence, the angle of reflected, and the normal line from here on out. Okay? So the incident ray is the ray of light. Coronavirus. I don't have the coronavirus. Okay, maybe I do. You'll get it through the computer screen. All right, so the incident ray is the ray of light falling on the mirror. Okay, so that's basically the incident. Okay, that's what it means. The incident is causing the incident. The normal is the perpendicular line where the ray strikes, so it's always a 90-degree angle, all right? The reflected ray is very straightforward, it's what bounces off. So therefore, the angle of incidence is the angle at which the incident ray makes with the normal, and the angle of reflection is the angle the reflected ray makes with the normal. Now, the mistake a lot of people make here is as follows. They think this is I, and they think this is R, okay? Remember, the angle of incidence is between the incident ray and the normal. The angle of reflection is between the reflected ray and the normal. Okay? You have to remember that. Now, your 2 things. What is a real image? It is an image formed by the actual intersection of light rays. What is a virtual image? It is an image formed by the apparent intersection. Okay? So when you look in a mirror, what you actually see, all right, is a virtual image. Okay, and insert joke here. Okay, so it's a virtual image. All right, so when you look in a mirror, what you're actually seeing is the ray of light go in, and you're seeing a virtual image. What you see in the mirror isn't actually there. Okay, all right, so what you see in the mirror isn't actually there. It's a virtual image. Okay, as you can see in the picture here, the rays of light go in and they form, and generally the distance behind the mirror is the exact same as the distance you stand in front of it. Okay. All right, so what we deal with in reflection, yeah, okay, and in physics, concave, convex, mirrors, curved, okay, all right. Now you need to be able to draw it. So the first one we're going to look at is concave, all right. So basically, very straightforward. Look at the back latter half of the word cave. In other words, it's caving in. So if you look at the mirrors here, this is caving in. You see? So concave, it caves in. All right. Now your ray diagrams, you need to know how to draw maybe 2 of the ray diagrams, and you could draw your image formation then from that, but they're very straightforward. Okay, remember in physics every action is an equal but opposite reaction. So the first, if the incident ray is parallel, as you can see here, this is parallel to the principal axis, which is the axis line here, it'll strike the mirror and come off through the focal point. Okay, very straightforward. If it's parallel to the principal axis, hits the mirror, goes through the focus. By law of Newton's law, therefore, if it goes through the focus, it should come out parallel. You see? So by drawing one, knowing one, you know two. You see? That's the trick with physics. An incident ray passing through the focus is reflected parallel. Okay? So two are down there. If it strikes the pole, it'll come off, okay, at an equal angle. That's number 3. Number 4, if you pass through the center of curvature, you'll be reflected back along your path. Okay, so there are your 4. You need to know about 2 to be able to draw it. Okay? Oh, and all the descriptions. Your pole is basically where the principal axis meets the mirror. Your focal point, okay, is the focal point of the mirror. It is halfway between the center of curvature and the mirror. Now the trick with this, the center of curvature, what does that actually mean? It is the center of the mirror. In other words, if you filled in this lens, you would have a mirror, a mirror ball. So the center of curvature is the center of the mirror. So from the center of curvature to the mirror is the radius. So therefore the focus is half the radius. Okay, so the focal point is always half the radius of your circle. Okay? So a real image will be formed in front of the mirror and a virtual image will be formed behind the mirror. As you can see here, we have an object here, P, and we have a line going parallel and it comes off through the focus. We have a line going through the focus and it comes off parallel. Okay? And where they all meet is your image. Okay? Now, don't worry about that. That's kind of just a thing. Your theory. In the log tables, you have this equation. 1 over u plus 1 over v equals 1 over f. Okay? So 1 over u plus 1 over v equals 1 over f. That is what's in the log tables. Okay? However, this is what you use if it is a virtual image. Okay? Now let's just say virtual there. So a real image, 1 over u plus 1 over v equals 1 over f. Virtual, 1 over u minus 1 over v equals 1 over f. Why is it minus? Okay, because that's your curve. Okay, and we put our object here, u. Okay, so let's say this goes in that way and this hits the pole. So we're not going to get a real image there. So if we pull this back, v. All right, so plus is in front of the mirror and minus is behind the mirror. So it's virtual because it's behind the mirror. That's what the minus is there for. Okay, all right. Or at least that's the easy way to think of it. All right. So the minus signifies it's virtual, it's behind the mirror. As you can see here. Now, key for a concave mirror, a convex for a concave mirror, it is virtual if the image is or the object is inside or at the focal point. So in other words, if you have the object at F or anywhere between F and the mirror, you will get a virtual image. Okay? And that's a common question they'll ask, is they'll say, find the focal length, you find the focal length, and they'll say, if we put the object here, are you going to get a virtual image? And if the object is, let's say the focal length is 10 centimeters, and they say, let's put the object at 5 centimeters, your answer straight away is it's virtual. Why? Because it's inside the focal length. Okay? So your magnification, in the log tables, you're just told m equals v over u. Okay? However, it can be written as height of the object, image, divided by height of the object, or image distance divided by object distance. Okay? Distance from the mirror, basically. Okay? So basically, height of the image, height of the object. Okay, that didn't come out very well at all, but you get the idea. Okay, so it means two things. Height of the image divided by height of the object. Image distance, object distance. Okay, so we'll start with our first question here. Find two positions in which an object may be put so that an image which is twice the height of the object. Okay, so what do we mean by that? So, an image, so that's V, is twice the height of the object. V equals 2u. Okay, why? Where am I getting that? I'll go back. What did I say? V over u. Okay, so V can mean height or image distance. U is object height, object distance. Okay, so because we're dealing with height here, therefore, the image, which is V, is twice the height of the object, which is u. So therefore, V has to be 2u. In other words, it's twice the height of the object. Okay? Formed in a concave mirror of focal length 50. Now, here you don't actually have to convert. So for optics, you can leave them in centimeters. Okay? Unless you're dealing with the power of the lens. You can leave them in centimeters. All right, so find the two positions where it can be put. So two positions What does that mean? That means we will have a real and we will have a virtual. There you go. So we start with the real. 1 over u plus 1 over v equals 1 over f. Okay? So v equals 2u. So 1 over u plus 1 over 2u equals 1 over f. Now, for some reason, students have awful difficulty with the following bit, and I can't understand it because it's basic maths, guys. Okay, so this is stuff you've been doing, or you should have been doing in junior cert and in your leaving cert. Okay, how do we solve for here? You make a common denominator. Do you remember that? So you have to find a common denominator. So the common denominator here is 2u. Okay, so there's two ways to do it. How I do it is I multiply the two unknowns at the bottom. So I would get, all right, so one way I would do it, okay, this is how I was trained to do it. The common denominator, you just multiply the two unknowns at the bottom. So that would give you 2u squared. And then you multiply the top, so that'd be 2u plus u. And then the u squared would cancel. And you get 2 plus 1 over 2u, okay? Now, I've been told recently they don't teach it that way anymore, okay? So I'm very old. So they say instead, now, this is probably what you do, okay? That's probably what you've been told to do. I'm going to roll this up because I need the space, okay? This is probably the new thing that you've been told. So you look at the two of them, okay? They can both go into 2u. So 2u is going to be our common denominator, okay? U goes into 2u twice. That's 2. And 2u goes into 2u once. That's 1. And I'm going to sub in my 15ths. Okay, so that's kind of an easier way to do it. Okay, I find that more awkward because I just, grew up doing the other way. So for me, I'm going to do the other way, but I'll try and remember to do this way for you guys. Okay, and after that, you just basically cross multiply. So in other words, you bring the 2u up there, you bring the 50 up here. So that's going to give you 50 times 3 equals 2u. U equals 50 times 3 over 2. So I got a u value of 75 centimeters. And for virtual, same equation, 1 over u minus 1 over v, 1 over f, okay? And 1 over u minus 1 over 2u equals 1 over f. So this time, oops. Actually, I'm going to just sub in my 50 because we know if f is 50. Now, we do the same thing again. So 2u is our common denominator. U goes into 2u twice. 2u goes into 2u once. The minus goes to the top line. So this time it's going to be slightly different. So it's going to be 50 times 1 equals 2u. So obviously u is going to equal 25. So if we put it at 75 centimeters, we'll get a real image. We put it at 25 centimeters, we'll get a virtual image. Okay? All right, so problem 2. So that's it, guys. They're fairly straightforward. Put your values on the left-hand side and work it out. So an object is placed 10 centimeters in front of a concave mirror of focal length. Find the position, the nature, and the magnification. Okay. Right. So let's look at this first. We can answer the nature of it straight away. Okay. So an object is 10 centimeters. The focal length is 20. The object is inside the focal length. So what's the nature of the image going to be? Virtual. So we know that before we even start. Okay. So what does that mean? That means the first thing we need to do, we need to find the position of the image. So we need to find V. Okay. And then we need to find the magnification. We need to find M. So we got the first bit. We need to find the next two. Now, even though we know it's virtual, you cannot assume it's, because we know it's virtual, you can start with the minus V, okay? 1 over u minus 1 over v, you'll get the same answer, but you already said it's virtual. But let's say you didn't realize that, you didn't cop that. How would you do it? You'd say, you start with 1 over u plus 1 over v equals 1 over f. 1 over 10 plus 1 over v equals 1 over 20. 1 over v equals 1 over 20 minus 1 over 10. Now, a mistake that people do not invert them and say 20 minus 10 is 10, v equals 10. Okay? That's wrong. V equals 20, 1 over 20 minus 1 over 10. And what that will give you is minus 1 over 20. So therefore, V equals minus 20 centimeters. And the minus means it's virtual. You see? So if you didn't cop up here that it was virtual, okay, you would do the equation, you'd end up with a minus number. So therefore the minus number means it's a virtual image. If you did cop it was virtual, you would have left V as minus, and the minus would have cancelled the minus, and you'd have get left to 20, but you already said it was virtual. Okay, so there you go. Right? Now, part 2, magnification, M equals V over U. Sub in your values. So that's, what's that? 20 over 10. No, not 2 magnifications. Sorry, centimeters, sorry. In other words, magnification is twice. The image is twice the object. That's all. Okay? See? Very straightforward, right? Right, convex. Convex are basically the other side of a concave mirror, okay? The image is always virtual, okay? So it's always a virtual image and always diminished. All right, so a convex mirror is always going to be a virtual image. You will not get a real image from this, okay? The rules, again, same. If it strikes the pole, it comes off at an equal angle. Number 2, however, if the ray was heading towards the center of curvature, it'll bounce off the mirror and go back through itself, all right? Number 3, if the ray was coming parallel, it'll bounce off and go off as if it came from the focus, and vice versa. The last one is obviously then, if it was going towards the focus, it would come off parallel. That's always the easiest one to remember because you just basically go backwards. That's it. So when you form an image, you get something like this. Okay, the image will always form back here because these arrows will never meet on this side. They all go off in different angles. So you would always get a virtual image. So your equation is always 1 over U minus 1 over V minus 1 over F. Can you tell me why it's minus 1 over F? Because the F is behind the mirror. Okay, so remember before I said it's minus V because it was behind the mirror. Okay, well, it's minus V because it's always behind the mirror, but also F is on the other side of the mirror. You see, the object is out here. The focal point is halfway between the center of curvature and the mirror. That's why it's always virtual, okay? Because the focal point is inside the mirror. So you're always going to get a virtual image. Okay, here we go. This is the last 2 questions of this, and we're done. All right, so an object is placed, I should better roll this up because this, it's fine there. An object is placed 20 centimeters, so U, in front of a convex mirror. Oops, no, 1 minute. An object, U, is placed 20 centimeters in front of a convex mirror of focal length, sorry, F is 12. Find the position, so we're looking for V, the nature, and the magnification. All right, so it's a convex mirror, so straight away we know nature, okay, and now we got to prove that 1 over U minus 1 over V equals minus 1 over F. 1 over 20 minus 1 over V. What am I doing there at all? Minus 1 over V equals minus 1 over 12. Minus 1 over V equals minus 1 over 12 minus 1 over 20. That should give me 2 over 15. Minus 1 over V equals 2 over 15. So V, 7.5 centimeters. Now, you see, this is why it's important to know it's a convex mirror. If you didn't cop there was a convex mirror, you didn't read it correctly, okay? You would say, oh, it's a real image because we didn't get a negative number. But it's not. It's a virtual image because it's a convex mirror, you see. For concave, this would be a real image, but we're dealing with convex here. So again, M, V over U, so that's 7.5 over 20. So the magnification is 0.375. So the object is 0.375 times. The image is 0.375 times the object. All right, problem 4. Where must an object be placed so that the image is 1/3? Okay, so the image is 1/3 the height of the object. So V equals 1 over 3 U. Okay? F equals 20 centimeters. Now, all right, so there's 2 ways to do this. I did it one way, which some people found difficult. So I'll do it my way, and then I'll show you the other way, just so you can do both, okay? So I left this as this, and I said, what are we? convex. All right, so 1 over u minus 1 over v equals minus 1 over f. 1 over u equals minus a third u equals minus 1 over 20. Now, if you have a fraction below a fraction, you take the bottom below the line and you put it above the line. So 1 over u minus 3 over u equals minus 1 over 20. So this becomes minus 2 over u equals minus 1 over 20. Okay, so you cross multiply, u goes up, 20 goes up, and we get u equals 40 centimeters. Okay, done. So it's very straightforward. V is equal to 1 over 1/3 u. Okay, so if you have a fraction below the line, you pull the 3 above and you're done. I just found that very easy. Okay, so that's one way to do it. So if you think that's fine, you understand that, you can turn the video off. The other way to do it is this way. You could do it this way. It's perfectly fine. You could say u equals 3v. So therefore 1 over u minus 1 over v equals minus 1 over 20. So we find v first. So 1 over 3v minus 1 over v equals minus 1 over 20. So this will become 3v. So that'll become 1 minus 3 equals minus 1 over 20. So that becomes minus 2. 3v equals minus 20. So that becomes minus 2 over 20. We'll get rid of the minuses actually. Equals 3v. All right, so that should give me 2 divided by 20. 1/10. And then divide that by 3. 0.33 continuous equals v. And we said v equals, so multiply that by 3. No, actually, hang on a minute, I did something wrong there. Let me go back and check my maths. What did I go error there? All right, so 1 over 3v minus 1 over v. All right, I made a mistake. Yeah, so basically we go back. I made a mistake here somewhere on my calculations. What went wrong there? All right, so 3v and v should form your 3v, okay? Oh, I think I know what I did. Yeah, so 3v goes into 3v once minus 3, okay? That becomes minus 1 over 20. So that becomes minus 2 over 3v equals minus 1 over 20. Yes, I divided across by 20. Yeah, there we go. I don't know why I did that. So I bring the 3v up. That becomes minus 2. Actually, do you know what? Get rid of the minuses here. Yeah, I don't know why I did that. No, that was a silly mistake. All right, so that becomes 2 equals 3v over 20. So that becomes 40. Yeah, there we go, equals 3v. There we go. I don't know, I divided across by 20 for some reason. Why did I do that? So 40 equals 3v. And we set up here that 3v equals u. Okay, so therefore 3v equals u equals 40. There you go. Okay, so I made a mistake there. I don't know why I divided across by 20. Anyway, so that's it. There you go. That's the mistake I made. But there you go. Same thing. So you end up working it down. You end up with 40 equals 3v. But we already said that 3v equals u. So therefore 3v equals u equals 40. Okay. A lot easier to just do the other way, but either or. Okay. All right. That's that topic, guys. You can leave your questions in the Edmodo page or in the comment section below. All the best.